Okay, so don't draw the diagram just quite yet. So this is what it looks like. So let's say we have molecule number 1. Okay, and this is as simplified as it can be, okay? So let's say it's like 2 atoms that are together. So here in this molecule, you would have 2 nuclei, okay? So let's say this molecule is very simple. It's like HCl or something like that, okay? So around the HCl, there's going to be electrons, okay? Now, obviously, this is like an over-exaggerated look to it because HCl doesn't have that many electrons, but the electrons are pushed out away from the nucleus, okay? So initially, these electrons kind of stay put where they are because they're attracted to their own nucleus first, okay? So this is what this molecule could possibly look like, okay? But let's say there's another nearby HCl. So molecule number 2, which has the exact same thing kind of going on. So there's 2 nuclei. It's got a flutter of electrons just around it that are kind of like being attracted to its own nucleus, okay? There can be enough electrons in the outside as far as possible to actually, instead of coming close to its own nucleus, it'll actually go find this nucleus instead. So there could be a potential attraction between the outside and furthest most electrons away from the nucleus to other nearby nuclei, okay? So there could be an attractive force between like those electrons to the other nuclei of the other molecule. Okay, so that's the nature of these London dispersion forces, is that every single substance on planet Earth, okay, molecule-wise, is attracted initially, has electrons attracted within it initially to its own nucleus, but then a weak type of attraction to stuff that could be even closer, okay, because it's so far away from there. Okay, so because of this difference and this kind of like attractability between those electrons and the nuclei, okay, some substances will have so many electrons that they can't really keep track of them. So they'll actually suck them in a little bit closer as opposed to maybe something that has a lot less electrons, okay? So the rule of thumb is that larger molecules, no, I'll do this first. Okay, larger molecules have higher LDFs. Okay, and the reason for that is just simply they have more electrons that are going to be possibly able to be distracted kind of like by the other nuclei that could be around it, okay? So it's hard kind of for that molecule to always keep track of its electrons because the nucleus at some point could be a little bit too far away. So instead, it's going to be attracted to a nearby nucleus of another molecule, okay?